Hello, I am Ishan Aras, and me and my team have created the Krushi Yantra bot, a bot dedicated to solve farmers' problems in terms of data collection of their cropping fields in the early stage, like for example, germination. This bot over here has an Arduino based system where we use 6 motors for moving it forward, backward, left, and right, and one special motor that controls the soil moisture sensor probe in the form of a rack and pinion design. Now, this rack and pinion design allows the soil moisture sensor probe to move up and down into the soil and out from it. Now, all of this is controlled using a Bluetooth terminal app that we use using our smartphones. Now, one more thing is that we use this bot and we show the output in the form of the LED. The LED is called a neopixel. Now, if it is below 20%, it shows a red value, indicating moisture levels are too low. 20 to 70 shows a green zone, which is ideally the optimal moisture level that should be there in a cropping field. And above 70% is blue. That means it's too much water in the soil. Now coming to our DHT sensor. The DHT sensor, or also digital humidity and temperature sensor, is a sensor used to check, like the name suggests, temperature and humidity of the environment around the pot. So these several features allow us to check several different characteristics and environmental factors that affect how the crop is managed. This is the Krushi Yantra project, and here's a demonstration for it. So, before we go forward with it, I would like to point out a few key details. This is the neopixel. This will turn red when the soil moisture is less than 20%, blue if it's more than 70%, and between the optimal range of 20 to 70, it will turn green. Also, here's the motor, and here's the soil moisture sensor, which will keep going down. This is the probe. We have arranged dry and wet soil to show you an example of how it works. So, here's a demonstration for it. So first, we'll connect it via Bluetooth. It shows it's connected. Now, we can move it forward. So now, it will check for the soil moisture reading. Oh, this shows that it is it's between the 20 to 70 range, and also you can see the real-time readings over here. It is right at 22%. The temperature is 22, and the humidity is 57%. This shows that the soil moisture sensor and the DHT attached over here are working perfectly well. So now let's check for more moist soil right in front of us. I'll move it ahead and I'll stop. So now we will put the probe in and check it once more. So now what we've done is we've placed it in the wet soil, and now let's input the command and see if it works. So here I've put the probe in the wet soil. So now let us input the command and see what the soil moisture level is. Okay, so as you can see here, the soil moisture level is 29%, which is a significant increase from the 22% seen earlier, and the temperature is 22 and the humidity is 57. This shows. So now let's take this back to its original position. So thank you, and I hope you enjoy our presentation. So as you saw from the demonstration, this bot works really well to give the farmer exactly what he needs in terms of the moisture sensor levels and also the environmental humidity and temperature. These are all key factors that the farmer must know before planting his crop. Now, this farmer can use these values and provide counter-effective measures that will help his farmland and ensure that his crops get the maximum yield. So now our bot also helps to maximize the sustainability of a farmer in his cropping field. So how does he do that? First, the moisture level that is recorded in the data, the farmer can take a look at that and also determine whether the moisture level needed is less or more. Now, in that moisture level that is recorded, the farmer can employ counter-effective measures. For example, if the water level is too high, he can manage it so that it gets to the right amount. Now, this moisture level is just one aspect of it. We also want to make sure that the bot runs on a cleaner energy source. So now, what are the future upgrades that we do with this bot? So number one, we want to shift it from an Arduino based system to a Raspberry Pi system. Now this will help us create localized files that help us data log with the time and date so that the farmer can have a good idea of what the cropping field has been like over a period of time. Now along with the Raspberry Pi system, you might have seen that the motors could use a little work. So for the same reason, we want to introduce a better system of motors with higher torque so that for a lower level of power, it can give a higher amount of movement. So those are the upgrades we want to use for our next edition. We are really excited to make this project work and hopefully bring it to the market. Thank you.